National 5, how are we getting on? It is Mr. Bull's Physics, and today we're in another installment in the National 5 course, and today it's one of my favourites, it's on space. So, let's jump in, but before we do, 94 subscribers. If you're subscribing to the channel, we want to say thank you, welcome to the family, and I'll let you know a little secret, we're trying to get to 100 subscribers before the September weekend. We'll only need 6 more. When we get to 100, I will do something fun. Okay, I'll put a video up that's fun. Don't know what it's going to be yet, but it's going to be fun. 100 subscribers, so subscribe. Anyway, let's talk about space. So, today we're going to be learning to introduce and develop the knowledge of space, things like terminology, words that we will need to use in space, questions that come up in the exam. And how we know we're going to do that? Well, we're going to find out understanding the challenges, risks and rewards of space exploration, which we'll come on to probably next time. And we'll develop and come in a new planet challenge. So if you're doing in class, then you might be doing this challenge. But for now, we're just going to look at the terminology and get a little bit excited about space. So, first of all, I want to show you some images of space. Now, space is an amazing, amazing thing. I get blown away every time I think about the universe, but there's some particular things I wanted just to show you, just to kind of get you excited about the universe as much as I am excited about the universe. So, this one here. This one is a black hole. You may have seen this. This was discovered about last year. And what's so amazing about this photo is that we normally can't see black holes. Black holes are these black objects that pull in light, and their gravity is so strong that light cannot escape. So nothing can come out of a black hole. So how can we see it? Well, we can't. That's why it's called a black hole. But in this one, what's amazing is that there's this disk around the black hole. This is called an accretion disk, and this disk is actually allowing us to see almost the edge of the black hole. And we've never seen that before. And what's also really cool is that when you see this light here, it's actually light coming from behind the black hole, because the gravity is so strong it pulls the light round and we can see it. So, an amazing, amazing photo. If you're watching this and you've not seen this before, then go search it up. There's a bigger picture of the context of the black hole. This is one of my favourite photos of all time. And this was taken by the Hubble telescope, and it was just pointed at a random spot in the night sky, and they saw what looks like here thousands, if not millions, of galaxies just in the one spot. And every dot looks like a galaxy. You've got spiral galaxies, irregular galaxies. There's loads of things here that have planets, stars, dust, asteroids, all of that stuff is in each of these galaxies, and there's so many galaxies. It's just quite, I don't know, makes you feel quite small when you look at that photo. One of my favourites. This one here, this one a wee bit closer to home. This here is a photo of when we're on Earth looking up at the night sky and seeing the Milky Way. Now, I hope you maybe have seen the Milky Way or seen some sort of stars in an area where it's not a lot of light pollution. But if you can look up, you can begin to see the streak of light across the sky with a wee bit of a bulge in the middle. That is the Milky Way. And it's amazing that we can look into our own galaxy. And I'm going to show you another galaxy, not specifically the Milky Way, but I'm going to show you where we roughly are in the Milky Way. But it's amazing that we can look into our own galaxy. And you can see this in the night sky if you go somewhere. I would encourage you to go to Eagle Ocean Wind Farm if you've not been. That is a great space close to Glasgow where you can see the Milky Way and see stars if you look long enough. Now, this is an example of a galaxy. Now, obviously we do not know what the Milky Way looks like because we can't take a spaceship up there and take a photo. This is just an impression or another galaxy that we think looks like ours. But we are roughly around about like here in the galaxy. That's why we can look into our own galaxy from the night sky. This would be called a spiral galaxy. You have different types of galaxies, and what's amazing actually though, just to point something out, is these wee dots here are very, very, very bright supernovas, and you can be quite amazed by how bright that looks compared to the centre of the galaxy. These are hugely bright stars, objects that have exploded and died, and we can see them. Okay. Now this one's really interesting. I love this photo because this is actually the furthest away star we have ever viewed in a telescope, and it's just this wee dot. So you zoom this up to here, and then this is it appearing here. Why is it appearing? Fancy term, gravitational lensing is allowing us to see into the past, so we can see this star. This star is 5 billion light years old. It has taken the light from this star 5 billion years to get to our eyes. 5 billion years. There's light that's travelled that long, boosted by this gravitational lensing, and allowing us to see the star. I'm absolutely amazing. Now, this one here is called the Eagle Nebula. And nebula is just a fancy word for a collection of dust and particles that will kind of come together eventually to form stars. And that's what these little pink and purple dots are. They're stars. Okay? Now, those stars are just at the very beginning of their life. Fusion has just started. And it looks like there could be many more planet stars from the formation of all of this nebula here. So, quite an interesting, what's called the Pillar of Creation, or Eagle Nebula. And we have our sun, alright, and our sun is very close to home again, and it's an amazing ball of gas and fire and plasma and heat and magnetism and all of these things. It is an amazing thing, and the stars are incredibly complex. People spend PhDs and their lives looking at stars. We've got some sunspots here, we've got some solar flares. This is our sun. Now obviously you don't view the sun in your telescope. You need a solar filter so that you can actually see without hurting your eyes. Now, that's all about space. I hope that was a little bit of fun looking at those images and makes you a little bit more excited about the universe. Please go and look at things like NASA website. They've got so many images of the universe. Now, what we need to know in National 5 is a whole bunch of space terminology. Now, this is stuff that we just need to know. We don't need to know the definition. You might be a space geek and you know all the space stuff. That's great, but you need to know how to actually say it in an exam to get the marks. So, if we look at some of these, let's just read them through. The planet. A planet is an object that orbits a star. It reflects light and produces no energy. Okay? That's how we would define a planet. A dwarf planet is the same as a planet but smaller and therefore not considered a planet. Alright? A moon is an object that orbits a planet and reflects light. So all of these reflecting light, okay, not actually producing energy. And an exoplanet is a planet that orbits a star outside our solar system and is so far away from the Earth we are unable to see it. Okay? So exoplanet out with our solar system. Alright? And then we have some more. So a star, a ball of gas which produces heat and light by a process of nuclear fusion. Nuclear fusion is one of the topics that we hoped you have already looked at, and involves when atoms come together and fuse together and create huge amount of energy. Alright? An asteroid is an object that is even smaller than a dwarf planet. Okay, we have the asteroid belt called the Kuiper belt, and we have beyond that we have like the Oort cloud. We've got lots of asteroids in our solar system, and we're very thankful for Jupiter, because Jupiter will actually take in a lot of the asteroids from the asteroid belt rather than them colliding with Earth. Alright. Then we have the galaxies, and galaxies are a system of hundreds of thousands of stars and dust that is both spinning and travelling, as we've kind of seen in those photos. And the universe is the whole of space which can be detected. Alright? Now the universe is expanding. Okay, the universe is getting bigger and bigger and bigger, and that is due to a whole bunch of cosmological equations that would be well beyond the scope of National 5, higher or advanced higher, but we know that the universe is expanding. It is getting bigger. Alright, in fact the universe is expanding faster. If you go far enough away to the edge of the universe, it's moving faster than the speed of light. Right, so the universe is constantly getting bigger. And I always think, how big is the universe? Alright, well, we can only see a part of it, but there's bits beyond that we actually have never been able to see because it's just so far beyond where we are. And I think, what is the universe? The spaces, there's a frontier right now of light that's going out into the universe. That light is going into space that no other light has touched. is that space? What is beyond that? If we were to walk in it, is it now part of the universe? But if we weren't, was it ever part of the universe? I don't know. Lots of amazing questions you can ask about space. Now, the sun is a star which glows, giving off both heat and light energy. Same as a star, it's just the same kind of definition. There are 8 planets forming the solar system. You know that. Pluto is not a planet. It was a planet. It's now considered a dwarf planet. Now, we know that we live in the Milky Way. We know that the Milky Way is forming as just a small speck in the life of the universe, and the universe contains everything. So that's just a rundown of all of the definitions you need to know for the National 5 exam. Okay, if you know them, great. Hopefully they're not too hard to remember. Now, we want to talk about a light year. I've said it a couple of times. What is a light year? A light year is the time it takes for light to travel, to travel in a year. How long does it take light to travel in a year? And it's a distance, it's a measurement. Space is so big, we cannot use meters. All right? We cannot say this thing is this many meters away because it's just too big. So we need to start creating new measurements for such large scale distances. All right. So for this one, we're going to look at light years. Now there's other things like parsecs or megaparsecs or astronomical units that you may be familiar with, but we're going to look at light years because it's a good way to calculate a distance. Now, light year is the distance traveled by light in 1 year, and it's called a light year. Now, how do we figure it out? Well, we should know that the light travels at the speed of 3 times 10 to the power of 8 meters per second. Okay, so that's what we have. Now, the distance travelled, therefore, by light in 1 second is 3 times 10 to the power of 8 meters. All right. Incidentally, it takes the light from the sun to reach Earth 8 minutes. So if the sun exploded, we would not know until 8 minutes time. Okay? Light, even though it travels fast and it goes into the universe, doesn't travel fast enough. So number of seconds in 1 year. So we're trying to find out what is the distance of 1 light year. Well, we need to find out how many seconds are in 1 year because we're going to be using the equation distance, speed and time. So 3,600, how did I get that number? 60 seconds times 60 minutes times 24 hours times 365.25 days. Why 0.25? Well, if you didn't know this, that's why we have a leap year, because the Earth actually goes around the Sun 365.25, not 365 days in 1 year. So therefore we have to, every 4 years, add in a little bit of a leap year, all right, to add a day to get ourselves back in line with the year, all right. Now distance of light in 1 year, so what we're going to do, this is just distance equals speed times time. We've got all of this, which is the seconds in 1 year, and we end up getting 9.5 times 10 to the 15 meters. Now, that's a calculation. You now know what 1 light year is. Every time you do a calculation though, I want you to assume that you're starting from the beginning again. Do not just take this number, because you can get the answer wrong at the end because it's not quite accurate enough. That's a rounded answer. Okay? So let's try an example. We're only going to do one example today, and that's us done. Nice and quick. But next day we're going to be looking more at space exploration and looking at rockets as well. So the question asks, the nearest star to our sun is Proxima Centauri, which is 4.24 light years away. Calculate the distance in meters, in meters between the two stars. So let's do this calculation. Now, the calculations should not be difficult. The calculations are just distance, speed, and time. So, distance equals speed times time. What is the speed? 3 times 10 to the power of 8 meters per second. 3 times 10 to the power of 8 times, and again, start in the beginning, 60 seconds times 60 minutes times 24 hours times 365.25. Sorry, I'm going off the page a little bit. Times by how many years? 4.24. And we put that in the calculator, we get 4.01 times 10 to 16 meters. Okay, it's as easy as that. Now, One thing you must know, if you're not looking for years, looking for hours, you'd just be doing 60 times 60 times how many hours. If it was days, 60 times 60 times 24 times however many days. So do not get confused by doing that. If it asks a different thing, you just need to find out the time it takes for that length of time, for days into seconds and stuff, and so on. Right, so if you are able to, I would offer exercise 21. I'll link it down in the Google Classroom. Have a go at that, see how the questions fare up. They're very straightforward, but any queries, just ask on the comments below. Okay, National 5, again, well done. Another great installment of the National 5 course. Looking forward to those 6 subscribers. Alright, a shout out might happen to the 100th subscriber if things are allowed. But well done, thanks for listening, and I hope you have a great day. National 5, how are we getting on? It's Mr. Bill's Physics here. Do you know what? It's pretty tiring doing that again and again and again when you make mistakes, but you know what? I'll keep going. I can't believe I'm doing this.